section 2.5. The first example is like the ones we had on homework. It's just a piecewise function. And what strategy did I tell you to do? What I want you to do when you graph these? You made a table. You made a T-chart for each piece. This one looks a little bit different because of my requirements. So we have the first piece, if x does not equal 0. Now I've told you if I put any kind of requirement over here, you have to put in that number. So I am going to have to plug in 0, but it said not equal to, so when I graph it, what would I put? Open circle. If it's not actually equal at that point, it will get an open. And then x can be anything else. So I could put in a -1, I could put in a +1, whatever I liked here, just to get a few points for my graph. Okay, so if I put in a 0, 2 times 0 is 0, 2 times -1 is -2, 2 times 1 is +2. So on my graph, I have an open circle at 0, 0, -1, -2, +1, +2. Which way does this extend? Both. It's everything except 0. All this is a line with one open circle in the middle.
All that little factors are dynamic range.
Well, yeah, and then to graph a little bit, but. The second piece says 1 if x equals 0. So the only thing I can plug in here is
0.
And we get out. So that's just a single point. So this one, we just have a line with 1 point removed. What is the domain? We do hit every x value. The orange line hits everything except the 0, but the purple dot fills that in. My range. So I'm coming from the bottom. I have everything except what number?
0.
So it would be -infinity to 0, union 0 to infinity.
Wait, what if you won?
We hit the 1, but that's included in the 0 to infinity. Questions? Okay. So I want to look at one other type of piecewise function. And I don't know, some of you have probably seen it before and some of you have not. It used to get taught in Algebra 2. I've heard that maybe it didn't last year. So we'll just see. The greatest integer function. So if you had Algebra 2 last year, you may not have seen it. If you had Algebra 2 before that, you probably have. So the greatest integer function, it has this double bar around x. That's what represents the greatest integer. And all it says is if you put in an integer, that's what you get out. So -2, -1, 0, 1, 2, 3. If you plug in any of those numbers, you get those out. Okay, if you put in anything that is not an integer, you get the greatest integer that is less than x. So if I put in 1.3, okay, 1.3 falls between what two numbers? 1 and 2. You give me the smaller number. So we get out 1. If I put in 1.9, 1.9 falls between 1 and 2. You always give me the smaller number. So 1.9 would give me 1. You have to give me some, you can't get out anything bigger than what you put in. So if I put in 2.1, what am I going to get out? 2. If I put in 5.79, 5. If I put in -2.3, think about this, negatives. So
-3.
-2.3.
-2.3 would fall between -2 and 3, so you would get out
Negative three.
-3.
Oh,
Okay.
It's like the opposite of that.
Hey, I was taught this, kinda.
Okay.
No, you were just talking.
So I just want to practice evaluating a few things. So if I said the greatest integer of -3, if you put in an integer, that is what you get out. So I just get out -3. If I said the greatest integer of 1.99,
1.
you get out 1. You have to think, what two numbers does it fall between? Give me the smaller. So 1.99 is between 1 and 2. The smaller number is 1. If I said -4.2,
-5.
right, -4.2 is between -4 and -5. You always give me the smaller one. All right. Can you handle just evaluating greatest integer if I just give you a number?
Yeah.
Okay.
Should.
Let's try to figure out what this graph looks like. So we are going to draw a graph for this function. All right. Anytime I have you draw a graph, we make a t-chart, right? So let's just start with something here. If I put in a 0, what would be the greatest integer of 0? 0. 0 is an integer, so if you plug 0 in, that's what you get out.
Would that be a closed circle then?
If we get that actual point, that is a closed circle on my graph, 0, 0. Okay, if I just put in a 1, what am I going to get out?
1.
A 1. If I put in a 2, what am I going to get out?
2.
So is this really helping me a whole lot? No. If I put in -1, we would get -1. If I put in -2, we get -2. But I need more. We're going to have to try something in between these. So let's say if I put in 0.5. What is the greatest integer of 0.5?
0.
So in that 0.5, I still get out 0. What if I put in 0.75?
0.
What if I put in 0.9?
0.
But I know that as soon as I put in 1, it jumps up here, right? So everything in between 0 and 1, I'm getting a number down here, and then all of a sudden I jump. So what we do is we put an open circle at 0, 1. We're going to stay down here on this line until you plug in a 1, and then we jump up here. What happens if I put in 1.1?
1.
If I put in 1.5? 1.9? So we're staying here, but as soon as I plug in a 2,
Go up.
I jump up.
This is that one graph from the homework.
It looks step.
Yeah, it's a step function. So just looks like this, and these steps, bless you. So as soon as you get one step, you really have them all. It just kind of continues. It doesn't stop. These just keep going. And so it's going to have a closed circle on the left, open circle on the right. It's just a horizontal line. If we can get one step when we're graphing this, then we can just complete the pattern to get some more. All right.
Is there a way to graph this on the calculator?
No.
Oh, we're gonna do transformations on that, aren't
Very minimal. We're not actually going to do transformations per se. I'm just going to have you make a t-chart, and we're not going to do anything too complex with these. Okay. So we'll try a couple of them together.
What was the reason why?
So if I said the greatest integer
Oh.
of x minus 2.
Was that not absolute value?
No, sorry, I can't. The keyboard doesn't have a good greatest integer function, so this is the greatest integer of x minus 2. Okay. Let's figure out what this looks like. So just start with our t-chart. If we plug in a 0, then we would have the greatest integer of 0 minus 2 is negative 2. What is the greatest integer of negative 2? So 0 gives me out negative 2. Okay, if I just plug in 1, yeah, then I would have the greatest integer of negative 1, which is negative 1. So 1 gives me negative 1. Is that enough to know what this looks like? Okay, so let's plug in something between 0 and 1.
1.6 or 0.7.
0.5.
0.7, 0.9, whatever you want. So if I put in 0.7, 0.7 minus 2 is negative 1.3. What is the greatest integer of negative 1.3? Negative 2. So when I put in 0.7, I'm still getting out negative 2. If I put in 0.9, 0.9 minus 2 is negative 1.1. What's the greatest integer of negative 1.1? So we are down here, but I know as soon as I plug in 1, it jumps up. So we've got an open circle underneath that, then jumps up. And that's really enough. I can see my steps. Just 1 unit long, closed circle on the left, open on the right. And we just follow our pattern.
So on these, is it reverse of, like, inside you, it would usually be to the right, but we went down 2.
Yeah, that's all it did, is it moved our original graph down. You can think of it, it's kind of like down 2, but it's also, if we had shifted right 2, it's the same thing. It's just a little harder to think about when you have so many different segments on our graph. When you graph these, I'm going to ask you to please put a minimum of 3 of these little steps on your graph, and then if you just want to put the dot, dot, dots on both ends to show the pattern continues. I'm not going to make you, draw 10 of them or anything crazy. Just a few.
I think we got it.
You've got it?
Yeah.
We're not gonna
The word problem portion of it's really ominous, so.
How
I
about,
don't like me writing in words.
let's do 2 more examples. One more, just graphing.
Huh? I missed
Okay, what if I said a negative greatest integer of x?
flip it like this.
So you could think about transformations, and any transformation rule will still work. It's a little bit harder with this, so if we just wanted to make a t-chart, we can. We really just need to figure out one step, and then we've got it all. So if you put in a 0, greatest integer of 0 is
0.
negative 0 is still 0. So 0, 0 is still a point on my graph. If I put in 0.5, greatest integer of 0.5,
0.
and put a negative in front, still 0. Okay, if I put in 0.9,
0.
and get the negative 0, which is still 0. When I put in a 1, greatest integer of 1 is, and a negative, we make it negative 1. So when I put in positive 1, we get out negative 1. So I was here. We know it started with a closed circle, so it's got an end with an open, and then it drops down. And if you just want to keep the pattern, closed on the left, open on the right. There's 3 steps, and I put my dot, 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 so it keeps going. Is that okay? Yeah.
Are we ever gonna write piecewise functions if you give us a graph?
I will not make you do that for this.
Okay.
Still look.
Not yet.
Okay, last problem.
I saw you thank you.
So I want to draw a graph to match this scenario. A real life example of a piecewise type function is male. No, if your letter weighs under a certain amount, you just have to put a stamp on it, right? But if you go over that, if it's in a certain weight range, you have to have 2 stamps, and if it's in a certain weight range, you need 3 stamps. So that's a type of gray signature function.
I sent it to Santa once.
You know about text messages? Do you have to weigh like good stamp those? I'll do mail.
I put it on notes.
Someday you might have to mail something. Someday.
And it's getting more technological, so like by the time like it's
I still mail.
True.
prominent, it's like just email them.
But someday you're not going to want to email wedding invitations out. Like you're gonna want to.
Oh, you're big
I
into that.
mailed out some stuff I was selling.
Someday you're gonna want to show off your kids and mail out Christmas cards. So
I mailed a bracelet to a customer, and it cost me 3 stamps. And I was like, "This is 3 pieces of yarn." It's just 3 stamps.
an express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph it on the interval 0 to 6. I am not asking you to write an equation for this. I am just asking you to graph it. Okay? So we're going to graph from 0 to 6. So those are my x's.
Well, why'd you do it like that?
Why is your 0? Oh, it's a 0.
Yeah, I mean, you could draw the whole grid. I just knew I wouldn't have any negatives,
I
so.
have negative mail.
Okay. We know it's going to cost at least $20. I'm going to count by 2s because I'm lazy. Okay. So first of all, it has a parenthesis on my 0. So what kind of circle will this start with? An open. Now, what is the absolute minimum it would cost me to mail this package? $20. So I'm going to put my open circle at 0.20. That is my starting cost. I know it's open because A, this started with the parenthesis. B, is there any such thing as a package that weighs 0 pounds, 0 ounces? Has absolutely no weight to it at all. No, that would be impossible. Okay, and we are going to stay here for everything up to 2 pounds. So if my package weighs 2 pounds, I'm still just paying $20 to mail it. But as soon as it goes over that 2 pounds, so if it's 2.1 pounds, what happens to my cost? Goes up $2. Okay, can I put another closed circle here?
No.
No, it's a function. So this would have to start with an open. And we're going to stay there for each additional pound. So if it's 3 pounds, I'm still just paying that $2 additional. But once it goes over 3, what happens to my cost? Goes up another $2. We'll stay there until we get to 4, and after 4 it goes up another $2 until we get to 5, and after 5 it goes up another $2. So if my package is 5 pounds, I could look at my graph and realize I'm paying $26 to mail it. If it's 6 pounds, I'm paying $28. Okay, I want to give you guys some time to